Stand in front of a mirror. Go ahead, try it. Raise your right hand. Your reflection raises its left hand, right? The mirror flipped you left to right, except it didn't. The mirror isn't flipping anything left to right. That's not what mirrors do at all. And this is going to bother you, because you've seen it your whole life. Every morning when you brush your teeth, comb your hair, you see this flipping happening. But it's not happening, not the way you think. You see, when you ask, why do mirrors flip left and right? What do you mean by that? Are you asking what the mirror does to light? Or are you asking why you perceive it as flipped? Because these are different questions, completely different. The mirror is just sitting there. It's a piece of glass with a reflective coating on the back. Photons hit it, photons bounce off. That's physics. That's simple. But your brain is doing something complicated. Your brain is trying to interpret what it sees, and that's where the confusion comes from. Now, let me tell you what actually happens. Physically, no interpretations yet, just physics. A photon leaves your right hand. It travels through space to the mirror. It hits the surface. The electric field of the photon interacts with the electrons in the metal coating. The photon bounces back. It enters your eye. That's it. That's all the mirror does. The mirror doesn't know about left or right. It doesn't know you're a person. It doesn't know anything. It's just a flat surface that reflects light. And here's the key thing. The photon that left your right hand comes back to your right eye. The mirror didn't move it to the left, still on the right. So what's going on? Well, imagine someone else standing in front of you. Not a mirror. A real person. They're facing you. Now, they raise their right hand. Which side do you see it on? You see it on your left. Their right hand is on your left as you face them. That's because they're facing you. Their right side is opposite your right side. That's just geometry. Two people facing each other, their sides are reversed relative to each other. Now when you look in a mirror, what are you seeing? You're seeing yourself. And you're trying to imagine what would it be like if I walked into the mirror and turned around to face myself. If you did that, if you walked forward and spun around, your right hand would end up where the reflection's left hand is. So your brain says, aha, the mirror flipped left and right. But the mirror didn't flip anything. You did the flipping in your imagination. By thinking about walking into the mirror and turning around, let me give you another example. Take a piece of paper. Write the word ambulance on it. Write it normally, left to right. Now hold it up to a mirror. What do you see? Backwards letters, right? The mirror flipped the text. But wait, did it? Think about what you did. You took the paper, you rotated it, you turned it around so the writing faces the mirror. When you did that, you moved the left edge of the paper to where the right edge was. You rotated it about a vertical axis. The mirror just reflected what you showed it. You're the one who rotated the paper. Now, you might say, well, I could have rotated it the other way. I could have flipped it top to bottom instead. Kept the left edge on the left, but flipped the top to the bottom. All right, try it. Write on a piece of paper. Now flip it over top to bottom so the top edge goes to the bottom. Hold that to the mirror. What do you see? The text is still backwards. Left to right, backwards, but now it's also upside down. So the mirror is still doing the same thing. You're the one changing how you present the paper to it. Here's another way to think about it. Write something on a transparent sheet, like an overhead projector transparency, if you remember those. Write on it with a marker. Now hold it up and look at it from the back, from the other side of the transparent sheet. The writing is backwards, right? But you didn't use a mirror. You just looked at it from the other side. That's because you reversed your viewing direction. You went from front to back. And when you do that, left and right appear swapped, because you're looking at the opposite side. The mirror does the same thing. It shows you the view from the other side, the back side, but it does it by reflecting light, not by you physically moving to the other side. What the mirror actually does, let me be precise about this, is reverse front to back along the axis perpendicular to the surface. That's it. If you set up coordinates, put the mirror in the XY plane, the Z-axis pointing out from the mirror toward you, the mirror transforms Z into minus Z. Front becomes back, back becomes front. It doesn't touch X, it doesn't touch Y. Left stays left, right stays right. Up stays up, down stays down. Only the forward-backward direction gets reversed. Now, you might say, but that's exactly what I see. When I look in the mirror, it looks like there's a world behind the mirror, and it's the reverse of the front. Yes, that's correct. Front to back reversal. But you said it flips left to right? No, you said that. The mirror flips front to back, always, every single time. You see, here's what happens. You look in the mirror, you see a person, that person looks like you, and your brain tries to make sense of it. Your brain says, if that's a person and they're facing me, they must have turned around. Because normally when I see a person facing me, they walked up and turned around to face me. And if they turned around, their left would be on my right. So your brain interprets the reflection as a person who turned around. And then you get confused because the person's left hand is where your left hand is, not where you'd expect it if they really turned around. But the person didn't turn around. There is no person. It's a reflection. It's you, but reversed front to back, not left to right. People sometimes try to help with analogies. They say, oh, the mirror swaps left and right, like flipping a photograph. All right, let's try that. You take a photograph of yourself. You hold it up. You're looking at the front of the photo. Your right hand in the photo is on the right side of the photo. Now you flip the photo. You turn it around so you're looking at the back of the photo through the paper. Now the image is reversed. Your right hand appears on the left side. So you say, see, flipping the photo flipped left and right, but I'd be cheating you if I left it there. Because the photo didn't flip itself. You flipped the photo, you rotated it, you're the one who did the flipping. The photo is just ink on paper. It doesn't flip anything. Same with the mirror. The mirror doesn't flip anything, it reflects light. You're the one doing the mental flipping, trying to interpret what you see. I can't explain the confusion in simpler terms because the confusion isn't about physics. It's about how your brain interprets what it sees. The mirror is innocent. Physics is simple. Your perception is complicated. And here's why it's particularly confusing for humans. Why we notice this flipping at all. Human bodies are symmetric left to right. Your left hand looks pretty much like your right hand. Your left eye is in the same place relative to the center as your right eye. Symmetric. But you're not symmetric front to back. Your face doesn't look like the back of your head. Your chest doesn't look like your back. And you're not symmetric top to bottom either. Your head doesn't look like your feet. So when you look in a mirror, you see someone who's symmetric left-right, just like you. That reinforces the feeling that left and right are the same, that they got swapped. But front and back are obviously different. You can see that front and back got swapped. Your face is in front. The reflection's face is in the mirror world's front, which is your back direction. Top and bottom are obviously different too. Your head is still up in the reflection, your feet are still down. So the only symmetry you have is left-right, and that's the one that confuses you. If you were a starfish with five-fold symmetry, you probably wouldn't have this confusion. You wouldn't think in terms of left and right at all. Or imagine if humans had a big red dot on their right shoulder and nothing on the left. Every human, always on the right. Then when you looked in the mirror, you'd see the dot on the same shoulder. You'd immediately notice, wait, that's still my right shoulder. The mirror didn't flip left and right. But we don't have that asymmetry. Most of our obvious features are symmetric, so we don't notice. Now, let me show you something. Do an experiment. Lie down on the ground, put a mirror on the ceiling above you, look up at it. What do you see? You see yourself. But now it looks like the mirror flipped you top to bottom. Your head in the reflection is where your head is. Your feet in the reflection are where your feet are. Wait, that doesn't sound like flipping. Let me say it better. In the reflection, you see yourself above you. And if there were really a person above you, lying on a glass ceiling, their head would be near your head, their feet near your feet. But their down direction would be opposite yours. They'd be upside down, relative to you. So now your brain says, the mirror flipped up and down. Did the mirror change what it does? No. The mirror is still reversing front to back, the direction perpendicular to its surface. But now that direction is up-down relative to you. So up becomes down in the reflections world. And left-right, left and right aren't flipped. Your left hand in the reflection is on the same side as your left hand. So why does it look flipped top to bottom now? Because you're thinking about it differently. You're imagining the reflection as a person lying on the other side of a glass floor. And if they're on the other side, their head is where your head is, but their down is pointing opposite your down. It's the same mental trick. You're trying to interpret the reflection as a person in a different position, and that causes the confusion. The mirror is doing exactly the same thing it always does, reversing front to back. I remember arguing about this with someone once. They insisted the mirror flips left-right. I said, no, front-back. So I said, all right, stand sideways to the mirror, turn 90 degrees. Now, does the mirror flip left-right? Well, your left side is facing the mirror. In the reflection, the left side is still the side facing the mirror. So no, left and right aren't flipped. Does it flip front-back? You're facing to the side. Let's say north. In the reflection, you're facing south. Front and back, relative to the mirror, are swapped. Wait, you say, but now it's flipping north-south, not left-right. Yes, because you changed what you call left and right. You rotated. But the mirror is still doing the same thing, reversing along the axis perpendicular to its surface. The labels you put on things, left, right, front, back, north, south, those are your labels. The mirror doesn't care about your labels. Let me tell you something that might help, or might make it worse, I don't know. In mathematics, we talk about different kinds of symmetry operations, rotations, reflections, translations. A rotation is when you turn something around an axis. You can rotate a book about a vertical axis. The book spins, but it's still the same book. A reflection is different. A reflection creates a mirror image, and mirror images have a strange property. If you have an object and its mirror image, you can't rotate one to look like the other. Not if the object is chiral, meaning it has handedness. Your hand is chiral. Your right hand and your left hand are mirror images. But you can't rotate your right hand to make it look like your left hand. You can turn it, flip it, spin it all you want. It's still a right hand. The mirror creates this kind of reversed image, an image that can't be rotated to match the original. But which direction gets reversed? Front to back. The direction perpendicular to the mirror. If you had a mirror that somehow flipped left to right without flipping front to back, that would be weird. That would be a different kind of operation, not a reflection. I don't even know what that would be, physically. And here's something else. In 3 dimensions, you can define handedness. Right-handed coordinate systems versus left-handed. If you have a right-handed coordinate system, X, Y, Z axis set up in a certain way, and you reflect it in a mirror, you get a left-handed coordinate system. Physicists use this. We talk about parity transformations, flipping one spatial dimension. So the mirror does change handedness. It changes a right-handed system to a left-handed system. But that's not the same as flipping left and right. It's about the overall orientation of space. Most of physics is symmetric under parity. The laws work the same if you flip everything in a mirror. But there are some exceptions. The weak nuclear force, the one responsible for certain kinds of radioactive decay, violates parity. It can tell the difference between left and right at a fundamental level. That was a huge surprise when it was discovered in the 1950s. Everyone thought parity was sacred, but it's not. Still, that's about fundamental physics, not about why mirrors look the way they do. This is getting technical. Let me come back to something simpler. Why do we have this intuition that mirrors flip left-right? Because we're used to seeing other people. When you see another person facing you, their left is on your right. That's how people work when they face each other. So when you see yourself in a mirror, your brain uses the same interpretation. It treats the reflection as another person facing you. And then it gets confused because the reflection's left hand is on your left side, not on your right side like it would be for a real person facing you. But the reflection isn't a person who turned around. It's a reflection. It's you, reversed front to back. If you could train your brain to see it that way, to see it as yourself with front and back swapped, it wouldn't seem like left and right are flipped at all. But you can't easily retrain your brain. Your brain has been interpreting faces and people your whole life. It's automatics. There are some interesting experiments on this, on how the brain processes mirror images. Babies don't understand mirrors at first. They think there's another baby in there. Around 18 months, they start to recognize that it's them. They reach up and touch their own face instead of reaching toward the mirror. That's called the mirror test. It's used to test self-awareness in animals. Some animals pass it. Great apes, dolphins, elephants, magpies, most don't. But even animals that pass the mirror test, that recognize themselves, Do they understand that the mirror flips front to back? Probably not. They just learned that the reflection moves when they move. We humans, with all our language and abstract thinking, we still get confused by it. So we're stuck with this confusion, this feeling that mirrors flip left and right, even though they don't. Mirrors flip front to back, always, every time. We think it's left-right because our brains try to interpret reflections as people who turned around. And that interpretation doesn't quite work. It creates a contradiction, and the contradiction feels like a mystery. But it's not a mystery of physics. It's a mystery of perception, of how human brains interpret the world. The physics is simple. Photons bounce off a surface. The surface reverses the component of their momentum perpendicular to the surface. That's it. The angle of incidence equals the angle of reflection. That's the law. Simple geometry. Everything else is in your head. Strange how something so everyday, something you see every morning, can be so confusing, isn't it? You think you understand mirrors. You've used them your whole life. But then you try to explain why they flip left-right, and you realize they don't. They never did. I'll tell you another thing that bothers people. Writing. When you write on a piece of paper and hold it to a mirror, why does it look backwards? Well, we already talked about that. You rotated the paper, but let me add something. If you write on your forehead with a marker, looking in a mirror, and you write it so it looks correct in the mirror, what did you do? You wrote it backwards on your forehead. If you could see your forehead directly, the letters would be reversed. You trained yourself to write backwards by watching the mirror. The mirror is still showing you the front-to-back reverse version, but now you're compensating for that. Ambulances do this. They write ambulance backwards on the front of the vehicle. Why? So when you look in your rearview mirror while driving, you see ambulance correctly. The mirror reverses it, and the reversal of the reverse text gives you the original text. But again, what's being reversed is front to back. The front of the ambulance is facing your mirror. The mirror shows you that front reversed. That's roughly where we are. The mirror does one thing. Front to back reversal. Simple physics. But our perception of it is complicated. Wrapped up in how we see people, how we imagine space, how we interpret symmetry. And maybe that's the real lesson. Sometimes the confusion isn't in the thing we're looking at. It's in how we're looking at it. The questions we ask, the assumptions we make. The mirror is just glass and metal, reflecting light, obeying simple laws of optics. We're the ones making it complicated. We bring our expectations, our experiences with other people, our assumptions about symmetry, and those expectations don't quite match what we see. So we invent explanations. The mirror flips left and right, but it doesn't. It's like asking why the sky is blue and someone tells you it's because the ocean is blue and reflects up. Sounds reasonable, but it's wrong. The sky is blue because of Rayleigh scattering. Short wavelengths scatter more than long wavelengths. Blue scatters, red doesn't. That's why the sky is blue and sunsets are red. The ocean is blue partly because it reflects the sky, not the other way around. We make up explanations that fit our intuitions, but nature doesn't care about our intuitions. The mirror flips front to back, that's what it does. Everything else is our interpretation, our confusion. Our brains trying to make sense of something that's actually very simple, interesting.